A dam is a structure built across a stream, a river, or an estuary to retain water. People have used different materials to build dams over the century. Ancient dam builders used a natural materials such as rock or clay, while modern-day dam builders often use concrete. Dams are built to provide water for human consumption, for irrigating arid and semi-arid land, or for use in industrial processes. A dam can be a central structure in a multi-purpose scheme designed to conserve water resources on a regional basis. Multi-purpose dam can hold special importance in developing countries, where a single dam may bring significant benefit related to hydroelectric power production, agriculture development, and industrial growth. Now, let's have a quick peek on ancient dams that still be used until this day. The Romans. Despite their skill as civil engineers, the Roman role in the evolution of dams is not particularly remarkable in terms of number of structure built or advanced in height. Their skill lay in the comprehensive collection and storage of water and its transport and distribution by aqueduct. At least two Roman dams in southwestern Spain, which are Proserpina and Cornalvo, are still used, while the other reservoirs have filled with leaks. The Proserpina Dam, 12 meters high, features with a masonry face core walled by concrete, backed by earth that is trained by buttress supporting the downstream face. The Cornalvo Dam features a masonry wall that forms cells. These cells are filled with stone or clay and faced with mortar. The merit of curving a dam upstream was appreciated by at least some Roman engineers, and the forerunner of the modern curved gravity dam was built by Byzantine engineer in 550 CE at a site near present Turkey-Syria border. Type of modern dam design nowadays. Most modern dams are from two basic types: masonry gravity design and embankment design. Masonry dam or concrete dam are typically used to block streams running through relatively narrow gorge as in mountainous terrain. Although the structure may be very high, the total amount of material required for such site is limited. Concrete gravity dams usually run in a straight line across a broad valley and resist the horizontal thrust of the retained water entirely by their own weight. The three main forces acting on a gravity dam are the thrust of the water stored in the reservoir, the weight of the dam, and the pressure exerted by the foundation. Embankment dam. Embankment dams are often preferred to control river and stream passing through broad, wide valley with only a very long barrier, requiring a great volume of material will suffice. Early embankment of earth fill or rock fill were often built as simple homogeneous structure with the same material used throughout. No effort was made at first to subdivide the dam into separate zones with the best suit material in each zone. Like a concrete gravity dam, the weight of an embankment dam deflects the horizontal thrust of the water pressure down to the foundation. The resultant pressure on the foundation must not cause excessive deformation, as this will result in failure. Unlike concrete, embankment dam material possess only limited resistance to water penetration. The rate of penetration depends on the pressure exerted by the water in the reservoir, the length of seepage path through the dam, and the permeability of the material of the construction. Soil and rock range from substantially impermeable clay through sleet and sand to coarse-graded gravel and rock fragments that possess a little resistance to the movement of water. In conclusion, the choice of design depends on the geology and configuration of the site, the purpose of the dam, and the cost factor related to material supply and site stability. Many dams are built for more than one purpose. For example, water in a single reservoir can be used for fishing, to generate hydroelectric power, and to support an irrigation system. Water control structures of this type are often designated multi-purpose dams. Now let's have a look how dams affect the society. Power supply. Hydroelectric power is made when water passes through a dam. The electricity is made by a device called a turbine. These are made of metal coils surrounded by magnet. The magnet spin over the coil to produce electricity. Turbines are found in dams. The water going through a dam spins the magnet. The energy made is clean and pollution-free. From this power, we can turn light on in our house. Irrigation. Dam and waterways store and provide water for irrigation, so farmers can use the water for growing crops. This idea goes way back into history. Irrigation is an important part of using water. In areas where water and rain are not abundant, like desert, irrigation canals from river and dam are used to carry water. Flood control. Dams help in preventing flood. They catch extra water so that it doesn't run wide downstream. Then operator can let water out through the dam when needed. The first upstream flood control dam was built in 1948, Cloud Creek Dam in Oklahoma. Clean water. Since the water stored in dam is fresh water, it can then be used for drinking water in nearby town and city. Some cities get their water river and stream in other states. The water is transported through a large canal and waterway. Recreation. Dam provide a wonderful opportunity for recreation. In building a dam, water is stored behind it. This water is called a reservoir. Reservoirs are used to store water, especially during time of excesses. They provide activities like fishing, boating, swimming, camping and hiking. Transportation. River and stream provide a great opportunity for transportation. Barges and ships can navigate along a river carrying a large load of food and merchandise. This type of transportation is effective because the load carried can be quite large.